Hello, this is the alternative delivery for. Today I'll address a question that someone posed via email. I'll make 5 comments and then we'll do chapter 4.2. In fact, let me begin with the comments. I am in the process of grading the chapter 2 quiz and concrete projects. So those will happen and those will be grades that will be assigned by me, and those will be passed back whenever contact is allowable. There were some of you who were preempted because of lines at the testing center from taking the chapter 2 quiz, and John has interceded for you and suggested that I let you take that later. So although grades will be posted, there's an opportunity for you to make up on that, not on the project, however. During this era, when we're doing online compensation and things like that, learning can happen well, but assessment becomes awkward. So I'm going to assign some assessments, and I'm going to, through the YouTube videos, give you an opportunity to grade these yourself and self-report them to me yourself for now. More about that later. After we're finished with this event, we'll probably go back to the testing center and a return to more normal things. But for now, active learning is required. You should have your book, calculator, and your YouTube remote in hand. And I'll also talk a little bit later about why you should love right triangles. But let's deal with the question first, and then we'll do chapter 4.4. The question a student asked is, he sent me this problem and didn't remember how to do it. I think we talked about this in class, but I'm not really sure. But this is how you do it. You have a swimming pool, but notice that this surface of the swimming pool is identical to this surface of the swimming pool, and those are right angles that are happening. So this is a gadget that we call a right prism, and the base is the same here as it is here. And we have a formula for a prism that says if I can find the area of the base times the height, that gives me the volume of the prism. And so that will tell me what is this measurement in cubic feet. So anyway, here is the solution then. So the volume is the area of the uniform cross-section, which in this case is a trapezoid, times the width. Now the formula for the area of the trapezoid is 1/2 the height times the sum of the bases, and so this is 1/2. It was 78. That's the perpendicular height. There's the sum of the bases, and then I multiply that by 50. I do all the arithmetic and round this off to the to 3 significant digits, I guess, and get 23,900. So that's how that problem should have been worked. One of the things that happens as you study trigonometry is if you just have an angle specified, then you can have a side and a side, but there can be 2 triangles like that. We can have the little triangle that has an angle of capital A, a side of lowercase b, and a side of A, but we also could have a bigger triangle that has an angle of A, a side of B, and a side of A. It's really pretty complicated. This introduces ambiguity, but for what we're studying, at least right now, right triangles pose no complicated ambiguity things, because we have nice things in a right triangle. We have the Pythagorean theorem, and we also know that these 2 angles are going to be complementary in that. So that makes things less complicated from ambiguity, but you have to be aware of similar triangles. If I just tell you what is the measure of the acute angles, that does not specify a unique right triangle. Okay, so now we're going to go through a series of problems, and many of them will look the same. We're going to solve the right triangle with the given parts. Now in 7 through 30, what you'll see is they're always saying the right angle is at C, so that is 90 degrees. So the answer there is always going to be 90 degrees, but you're given different information. For example, in problem 2, you're given that angle A is 51.36 degrees, and side A is 3,692. So you have those entries that you can put into the table, but you have to find the remaining entries. So what you should do is pause, use your right triangle trigonometry and notes and so on and so forth, and Pythagorean theorem to solve this problem. And so pause the video, solve the problem, and come back and compare your notes. We're back. Hope you did pause that. If you didn't, you're actually shortchanging yourself. Okay, so what we can do is we can say the sine of angle A is going to be A over the sine of A, and so A over C, excuse me. The sine of A is A over C, and that means C can be solved for, so C is A over the sine of A. Well, we know those things because we can find the sine using our calculator, and we also know what C is, so we can calculate C. We plug in the numbers and we get this value. We also know that the tangent of A is going to be A over B, and that means that B is going to be able to find out by putting A over the tangent of A, and we know what A is again, and so we can solve that, and we get this as the value for B. And lastly, because the acute angles add up to 90 degrees, they're complementary. That means we can just subtract from 90 and find out that value. So that's how you would have solved that problem. Now here's another problem, but this time they give you the length of side B and the length of side C. So you have to find all of these angles except for A, and you have to find side A. So pause, get your calculator, and work through it, and we'll compare notes. Okay, on this problem, then what happens is we'll use the Pythagorean theorem, but this time we know the hypotenuse and one of the sides. We have to use it to find the leg. So the Pythagorean theorem works this way. It is c squared minus b squared is equal to a. We use our calculator and we get a is this number. Now we know that the cosine of a in the triangle that we have is b over c. And that means that A is going to be the inverse cosine, or arc cosine, of B over C. I plug those in, I use my calculator, make sure I'm in the degree mode, I get this answer for A, 86.674 degrees. And then what I can do is I can say, and also the sine of B is going to be B over the hypotenuse. So that means that capital B is the inverse sine of that ratio. And so the angle B is 3.326 degrees. So again, a different kind of problem. The next problem that we have gives you angle B, but then the side A. So angle B and side A. And so we must use that to complete this table. Please pause, and we'll look at a solution in a moment. Okay, here's the solution that we get. We know that the cosine of B is going to be A over C. That tells me that C is going to be A, that number that we know, divided by the cosine of B. And the cosine of B we can find, so we do that calculation with our calculator, and we get that C is 84.087. We also know that the tangent of B is going to be B over A in our triangle. That means that B is equal to A tangent of B, and this was the value that we had for A, and that is the tangent of B. We plug that into our calculator, and B is 83,760. I may actually put a decimal point in here. I think that might have been a different, actually I don't think there is a decimal point there because I'm seeing this. So we get this for B, and to find angle A, we subtract that from 90 degrees, and we get the value for A. Here's the next problem. This is number 28, and we're given sides A and B. So we're going to use the Pythagorean theorem to find C, but then we have to find all of these angles except for C, which we know to be 90 degrees. Pause your calculator, or pause your video, work the problem, and then check back. Okay, so C is going to be the square root of A squared plus B squared. You plug that into your calculator, you get 16.4. The tangent of angle A is going to be A over B, the opposite over the adjacent. That means that capital A, angle A, is the inverse tangent of that ratio, and you plug that into your calculator and you get 4.49 degrees. The tangent of angle B is B over A, and that's going to be the inverse tangent, and we're going to get 85.5 degrees. A and B in this case are going to be complementary angles, and that would have been another way to have solved that problem once you got to that stage. Now we come to problem number 30, I guess, and we're given A is this value and B is this value. So pause your calculator and work through it. Or pause your video, excuse me, and work through it. Well, you see, they told me what the small angles were, but that's not a unique triangle, so there's not a unique answer. Okay, let's look at a few other problems. Here, we're not giving you everything. We're just saying you want to find A up here and find X down here with that given information. So please work through those two, pausing your calculator and pausing your video and using your calculator to find these answers. And compare notes. So the tangent of the thing called A was that ratio. That means A is the inverse tangent of that ratio, so A is 28.5 degrees. In the other figure, we have the sine of 22.45 degrees is X over 72.65, so I multiply those numbers together, and this is what I get for my answer for X. Life is a word problem, and sometimes there are word problems. I'm going to ask you to look at problem 36, where they're giving you one leg and the angle opposite this leg, and you need to find the other leg. And number 38, the legs are, given those, you need to find the larger acute angle. So pause, work the problem, and come back and compare. Okay, so here what we find is that 8.5 over A is the tangent of 52.3 degrees, and that means that lowercase a is, I solve for it, is 8.5 over the tangent of 52.3. That, and I do the calculation, I get A is 6.57. On the other one, what I find is the tangent of B is this opposite over adjacent, so B is the inverse tangent, and I found out that that is 54.7 degrees. Two more word problems I'd like for you to think about. The first one is problem 40 up here, and the last one is this screen of the Samsung Galaxy tablet, and there are different questions asked. So pause, read the questions, work them both using your calculators, and return to talk about the answer. Okay, let's talk about 40 first. The circumference is 20 pi, that is 2 pi times the radius. That's one of the formulas that we have, and that's one of the good things about this being an open book thing. That means that the radius is 10. And so we have an angle where the radius is 10, and we know each of these angles is 60 degrees because it's an equilateral triangle. That means this is a 30, 60, 90 right triangle. So that's what we have for that. And this is a triangle that, remember, the sides are in the ratio of. This is going to be 5, that is going to be 10, and then it's going to be 5 times the square root of 3, because that's the way a 30-degree angle down here is going to work. And so that means that what we have is it's 1/2 the base times the height, so it is going to be, let's see, oh, that was half the length. So that that base is that, and let's see. We know that that's 5. Hold on. Oh, the longer leg. The longer leg has this, and that's the leg there. That's 5, and that's half the length of one side of an equilateral triangle. And we knew that the triangle was. Oh, that's half of it. So we know that the area is 1/2 the base times the height, and that's going to give us the base that we're taking that to is there. So we're going to get 6 times 5 square root of 3 for the area of the entire triangle. On the other one, we have to find C. We use the Pythagorean theorem in our calculator, and the angle A has cosine of A being B over C. And so A is equal to the inverse cosine of that ratio. We use our calculator to find out that's 36.87 degrees. And that means the length is going to be this, and the width is going to be that. And you really wanted to draw a picture from the words in order to feel good about that. Okay, so it's time for our benediction. Time is precious. Each day must count. Do the math. It will make you strong. John does have availability over the phone, and he's more than willing to help you. Make sure you're doing the problems that he is assigned. Take care of yourself.